Welcome to Study Loop.
So if we look at equation 23.9, we find the relation between height and the image distance. So height of image over height of the object should be equal to negative height of distance of the image over distance of the object. Now the way the sign works is if the image is inverted, if the image is inverted, then we take negative sign. We take negative sign. Um, and for camera, the image is always inverted, so we can take di as negative for our case. So the final equation becomes hi, which is equal to h naught times di over d naught, and we know all the values. So for our case, h naught is 1.4 times 10 to the power 6 kilometers. Then this image distance is 28 millimeters, and the object distance is 1.5 times 10 to the power 8 kilometers. Now the reason we took di as 28 is because since the object is very far away, we know that the image that forms behind the lens is always at the focal point. So that's why, since our focal length is given, we can take our focal length as our image distance. So, and that's what it gives us. So that's part A, and that gives us our hi as 0.26 millimeters. Sorry, 0.26 millimeters. Now we can do the same calculation for part B and C. So I'll leave up to you to do the calculation, but it's the same. Only thing that will change is the DI. And for part B, for 50 millimeter, sorry, for 50 millimeter as our DI, the height of the object will be 0.47 millimeters. And for C, when we have a focal length of 135 millimeters, the height of the object will be 1.3 millimeters. Okay, now we have to find out the magnification. So we know that 50 millimeter is the standard. So that means for 28 millimeter focal length, the magnification is going to be 0.56x. So that means it will be smaller than 50 millimeters. And for 135 millimeters, this will be 2.7x. So it's gonna be 2.7 times 50 millimeter, 2.7 times of 50 millimeter focal length. Thank you.